Hello, in this lecture we're going to talk about the hydrogen spectrum. As in the last video I've told you about the spectrum. Now, to make a hydrogen spectrum, the first thing that need to be confirmed is that it is not a hydrogen molecule, it must be a hydrogen spectrum individually. Now for that we're gonna just enter the hydrogen gas into a Crookes tube or discharge tube, and by just giving it the negative charge we're gonna just break these bonds of hydrogen molecule, or as we know that hydrogen gas is H2, so we're gonna just break these bonds between the hydrogen and it will become an individual hydrogen atom. Now to this hydrogen atom we're gonna just give it sun rays. Now here the way of energy giving we used it as a sun energy. Sun energy we have used here, sun energy. Now as we know the atoms or the molecules or electrons in hydrogen atom is in K shell. It is K shell. Now by giving it energy we're gonna just make this electron to go upwards. Now here we know that a sun energy has three parts, as I told you in previous videos: ultraviolet rays, visible rays and infrared. Now here we know that ultraviolet rays has more energy as compared to infrared. Now here when we give the ultraviolet ray, now this hydrogen will go up, and as we know the ultraviolet has high energy, so it will fall more because it is more unstable. Now when it will fall, it will create a line spectrum like this. First it will fall to Q shell, then P shell, then O shell, then N, then M, then L, and then after that L, K. Now when it will fall on K, we will say that it becomes stable. Now the hydrogen that goes upwards with respect to visible rays, it will fall on on Q shell, then P shell, then O shell, then N shell, then M shell, and then on L shell, because it has less energy, or we can say that it has medium energy. Now when electrons goes up with respect to energy of infrared, it will fall on Q, then P, then O, then N, then L. It will not fall on L because we know that infrared rays has less energy. Now here the infrared rays starts from 10 raised to power 5. Now we know that as infrared rays has less energy, it must have more parts because it also consists of the microwave and radio frequency. Now let me just tell you by this graph we got three parts: ultraviolet, visible, infrared. Now here for the ultraviolet we got series like this. First the electron from infinity falls on it, then 7, then 6, then 5, then 4, then 3, then 2. Now the line spectrum must be like this. This is a straight line. Now this kind of series is known as Lyman series. MCQs of Lyman series came like this: M 2 1 is equal to 1. Now here when it says that the shell is 1, or we can say that K, we're gonna just identify that it is a Lyman series. If it says that N 1 2 is equal to 2. So we're gonna say it is a balmer series. Now we know that visible rays has range from 400 nanometer to 750 nanometer. So we're gonna say it is visible. Now these series are known as balmer series. Now the last one, infrared. These series are known as paschan spectral series. Now the paschan spectral series also have more two parts. In the first part, or we can say that microwave, it falls on N shell. It does not goes to M shell. It falls on N shell, and it is known as bracket spectral series. But from where the IR, infrared, is more far, or we can say that radio frequency, it falls on only O shell because it has less energy. We know that the things that are more far has less energy, but the things that are nearer to it has more energy. So the summary of that is, if the shell is K or 1, we will say that it is a Lyman series. If the shell is M, or we can say that 2, it is balmer series. If the shell is 3 or N, we're gonna say that it's a paschan spectral series. If the shell is 4, it is bracket spectral series. If the shell is 5, it is pfund series. It IR has two parts, bracket spectral and pfund series. And this is all about today's lecture.